In this video, we're going to explore surface area of prisms. Before we do that, though, we have to have some definitions on what exactly are we doing, what does surface area mean, and what is a prism? Well, the total surface area is defined as the sum of all the area of all the faces and the bases of a 3D solid. So in other words, all the faces. Every single shape that is formed by a prism is going to be added up, the area of that. And that's going to give us our total surface area. Sometimes we abbreviate that as surface area or total surface area or total area. It's really the same idea. So they're all interchangeable terms. The lateral area, though, is the sum of the area of the faces of a 3D solid, not including the bases. So basically, it's all of the lateral faces, all the way around the sides. So it's not including those ones on the bottom. And a regular prism is a 3D solid that has two identical bases. Now the bases are congruent, and they're also going to be parallel. So an example of a prism is what's called a triangular prism. And yes, the name of the shape is given by the base, but the fact of the matter is, in this triangular prism, we are going to have two triangular bases and three rectangular faces. So right over here, this triangle that we're seeing here, that is one of our bases, and then we have an identical one on the other side that's congruent. It's exactly the same. Then we have a rectangular face here, one on the bottom, and then one over to the side. Now, depending on the type of triangle, those rectangular faces may be the same or they may not. But what they do have in common is this length connecting the bases is exactly the same. Another example would be a rectangular prism, which has dimensions of length, width, and height. Technically, we don't really have bases for a rectangular prism because if we're using the definition of the base is essentially not the rectangle, well, there is no such thing in the rectangular prism. And so then we also have a hexagonal prism, which has the same basic properties of the two hexagons, one right here and one right here. Those are going to be your bases because those are the identical parallel sides that are not rectangles. And then in this case, the hexagonal prism has 6 rectangular faces. So let's get to some worked out stuff here. So in a triangular prism, the shape of the base is a triangle. And the hexagonal prism, the shape of the base is a hexagon. And just to kind of to clarify a little bit, when we have right here the face shape, when we're talking about how many faces, we're talking about lateral faces. So slightly different from just saying a face, but a lateral face. A little omission there. So in a triangular prism, in a rectangular prism, in a cube, in a hexagonal prism, all the faces are rectangles for the lateral faces. The bases, though, are going to be whatever shape the prism is. So how do you determine the shape of the base? The base is the shape that's not the rectangle, and more importantly, it's the part of the prism that has the congruent identical bases, the congruent identical face, whatever it happens to be. Triangular prism, it's a triangle. Hexagonal prism, it's a hexagon. In a prism, any prism, the faces are rectangles. Your lateral faces are going to be rectangles. And again, the bases, the number of sides of the base and the number of faces of the prism are exactly the same. So in a triangular prism, 3 rectangles, hexagonal prism, 6 rectangles. If we went to like an octagonal prism, we would have 8 rectangles. And cubes and rectangles are similar because they don't have bases, but the difference is what those faces actually are. Are they squares, are they rectangles? In a rectangular prism, the faces are rectangles, but in a cube, the faces are going to be squares. So rectangles and cubes do not have lateral area, but they do have surface area. Why is that true? Because we haven't clearly identified a base in the rectangular prism or the cube. Now, we're not worried about formulas so much in this section. It's more about process, procedure. How do we do this? We're looking at the lateral area. We're looking to add up all the area of all the faces that are not the base. So in other words, all of the rectangles that don't happen to be, like if you're looking at a rectangular prism, there is no such thing as lateral area. Surface area is your lateral area plus the area of your bases. So it's everything we did before. It's the area of everything, all the faces. including the ones that we specified as bases. And so how do we find the surface area of a rectangular prism? We're going to find the area of each rectangle, and we're going to add them up. Now for a cube, we do have a specific formula because we know in a cube that the faces are all made of not rectangles, but squares. So the area of one square is s squared, and there are 6 identical sides in the cube, so we're going to call it 6s squared for our surface area. And we've got some worked out examples. Just go through a couple of them real quick just so you can see the process of how do we find lateral area versus surface area. The surface area for a rectangular prism is all of the rectangular faces added up. We do not have lateral area because we haven't specified a base. So in this surface area, we're going to take 2 of each of the rectangles that we have. We have really 3 different types of rectangles. We have the ones that are at the top and the bottom that have the same dimensions of 4 by 5. We have the ones on the sides that are 4 by 10s, and the one in the front and the back, which are 5 by 10s. So the surface area is going to be 2 of those 4 by 5s, 2 of the 4 by 10s, and 2 of the 5 by 10s. When we multiply those and add them all up, we're going to end up getting 220 square centimeters for our surface area. When we're dealing with a triangular prism, though, we do actually have lateral area. The lateral area are these rectangles. So you'll notice here we have this 18. That 18 is not only the dimension here, but because we have a rectangle, it's the dimension here, and it's the dimension here. So every single rectangle we have has a shared common dimension of 18. The other dimension is given by the dimension of the triangle. So the rectangle in the back is a 9 by 18 rectangle. So that would be represented by this one here. On the bottom, we have a 12 by 18 rectangle represented here. And kind of going along the slant here, we have a 15 by 18 rectangle represented here. When we add all the areas up, and it looks like it got cut off here, but we end up getting 648 square centimeters for the lateral area of the triangular prism. The surface area, we're going to take that number and we're going to add to it the 2 bases. So each base is going to have a base of 12 and a height of 9. So we can take 1/2 of 12 by 9 and then 2 of those. And when we add those in, we end up getting 756 square centimeters. Same idea for the hexagonal prism, but instead of having 3 rectangles, now we have 6. And instead of them being different, this is a regular hexagon, they're all going to be the same. So that's good news, because if we can find the area of one, we can just multiply it by 6. Well, to do that, we know that the sides are going to be 2 all the way around and a height of 5. So each of these rectangles that we see has a dimension of 2 feet by 5 feet. So there are 6 of them. We can take 6 times 2 times 5. It's going to give us 60 square feet for your lateral area going around. Add to that your base, and we said in a hexagonal prism, to find the area of that, there are 6 equilateral triangles. And in this case, they have a height of, or side of 2. So we can use the formula 1/4 side square root of 3. One triangle has an area of square root of 3, but there are 6 of them. So our first base, this one here, has an area of 6 root 3. There's another one on the other side that has the same area. So we're going to add both of them in and get 60 plus 12 square root of 3 square feet. All right, and then one more, number 6. We have that cube. So again, that cube, we have that special formula. Very few formulas in this particular unit, kind of intentionally. But if we look at the side squared, we have 8 squared, which is going to give us 64. And then we can multiply that by 6 to give us 384. Again, lateral area is all the lateral faces. Generally speaking, they're rectangles. The surface area is all that lateral area plus the 2 bases. Again, rectangular prisms and cubes do not have lateral area, but they do have surface area.